making them a ball now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a ball now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? this thing on now? I've been walking long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been walking long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? my bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 40-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We feel it inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, cracking in my bone now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah.
There we go. Hello, everybody. We're here again for another Unreal Engine Australia short film challenge training session. That's it's a heck of a long acronym, so I've got to find a nicer way to say that. But welcome, everybody. Today we're going to be covering scripting fundamentals, and this should be a fun one. I'm covering a few topics that filmmakers may not expect as important. But I really think having a broad knowledge of the engine goes a long way. So for this session, we're going to begin by kind of running through Blueprint and the basics of what Blueprint is and how it works. And then after that, we're going to be moving on to what we call editor utility widgets. Now, Alex Stevens is going to be running that section. And that's going to be focusing on how to make your own tools for the editor. So for anyone that is just joining us for the first time, my name is Chris Murphy. I handle evangelism in Australia, New Zealand, and Southeast Asia. My role is just supporting developers, and it's a bit of a strange one. Pre-COVID, there was a lot of flying around and helping out with different teams and seeing different kinds of problems. And at the moment, there's a lot more on the webinars and calls front. So I was brought in to kind of help folks out. My background is as a technical artist, so I was brought in to kind of help folks get a general idea of some of the fundamentals of making things inside of real-time worlds. Now on the call, outside of myself, there's actually Alex Stevens, who's another evangelist with an engineering background. And then we have Tony Reed as well. And Tony Reed is the territory manager for this part of the world. So we're going to be going into this today with the stylized kingdom setup. So this is the world that we're kind of using. I decided last night that it was probably a good idea if I stopped making everything Paragon related. So I might do something that's a little more on the adorable side. And we're actually going to begin by looking at how to create some basic things inside of Blueprint. And once we have the basics going in Blueprint, we're going to be looking at creating our own characters. So the characters are going to be testing for AI, and as well as having basics of AI, we're also going to be setting something up to have something playable. So what I mean by that is we're going to have something that allows you as a player to kind of run around in the world as a person. Now, the reason I wanted to do something playable is because we actually can record anything the player does and their animations back into Sequencer. So you can create some pretty crazy effects by doing that. But we'll get onto that a little bit later on. So let's begin by looking at a basic environment. And for just 1 minute, I know I said I was going to use the adorable landscape, but for 1 minute, I'm going to actually give you a pretty clear-cut, empty-ish environment. And the reason I want to do that is I want you to have an idea of Blueprint in its cleanest form, and then I'm going to come back to this stylized kingdom. Okay, so I'm going to go into my defaults, and I'm just going to get this environment, and I'm going to delete everything that's here just for the minute. Okay, so we've just got a totally bare bones environment here. Okay, now the reason that I've set this up is I wanted to kind of run through like if you were starting something in the world with what we've covered in the last couple of days, by now I'm sure many of you are aware that we can drag the sun into a scene. Okay, now when we drag the sun into a scene, as we covered in the outdoor environments, we can set this up to be a atmosphere, fog, sunlight, which tells the engine that this light represents the direction that the sun is in. And I'm able to drop in a sky atmosphere, which will automatically respond to that. Okay, so once again, we're all probably used to this kind of setup going on, where we can see the sun moving through and the atmosphere adjusts to it. I'm going to drop in some height fog just because I like getting rid of that blackness that was down the bottom. Okay, now this is reasonably simple. So what I would like to do is imagine for a second that we wanted to get all of these things and we wanted to create a mechanism that we could control this ourselves. So what I mean by that is I'm actually going to delete the directional light, the height fog, and the sky atmosphere for just a minute. Don't panic, they'll come back. And I'm going to go to my content browser, and I'm going to create a new Blueprint. Now, Blueprint is Unreal Engine's scripting language, okay? So this is what we use for creating a lot of our own stuff. And it's worth noting that there are plenty of games and films that have been made that haven't touched any C++. They've literally just touched this Blueprint layer. And the point of Blueprint is to be accessible to the entire team and let everyone have a more stronger collaboration. So I'm going to go ahead and I'm going to create a new actor. Now, an actor in Unreal Engine refers to anything that can be placed inside of the world. So if it has a position, a rotation, and a transform, position, rotation, and scale, also known as a transform, it's going to be an actor. Now I'm going to create something that I'm going to call BP time of day. Okay, reasonably clear cut. And I'm going to open this up. So this is Blueprint, this is what we see, and there are three aspects to it: the viewport, the construction script, and the event graph. Okay? Now in this situation, I'm going to be creating a couple of extra things. I'm going to go through and I'm going to recreate the stuff that we just saw inside of our scene. So I'm going to add a directional light that I'm going to call sun. And on this, I'm going to add the property for an atmosphere fog sunlight. I'm going to add another component, which is going to be an arrow component. This just gives me a big red arrow that points in the direction that the sun is currently facing. Okay, and you can see that it's parented to the sun. See this hierarchy up here? This means if the sun rotates, the arrow will rotate. Okay. So now that we've got that in there, I'm going to add another component. I'm going to add a sky atmosphere. Doesn't matter where this one is set to. And once again, I'm going to add a height fog. Actually, I'm going to get rid of the height fog because I wanted to eventually read from the sky atmosphere. All right, so we've got this, and if I was to get this time of day and I was to drag it into the scene, this is what we would see. Okay? Now, you're probably like, but Chris, this is essentially what you just made. Why are you wasting time? Yeah, okay, that's a good point. I see your argument. But let's look at what this means. If I was to get this actor, and I was to say, rotate the sun to here, and hit compile, it's always going to default to this kind of setup. Do you see that? But more importantly, let's look at the real strength of Blueprint. Now, the real strength of Blueprint isn't the fact that I can just bundle things together. You know, if we could bundle things together, that's kind of cool. What's really cool is this. If I go to my event graph, the event graph allows me to add functionality to Blueprint. So what I mean by that is the event graph allows me to add logic to how this thing should behave. Now, in this situation, I'm going to take control of a thing called tick. Now, how this works is, I'm going to switch to a camera for this. If you imagine that we were playing a game, right? And I was to throw my phone across the room. As this phone moved through the air, every single time the game goes to update, it would say to my phone, all right, where were you? How fast are you moving? And how long has it been since we last updated the world? Okay? At which point it would then multiply its velocity and its direction against the time that it's been moving. Okay? And all of a sudden, what we end up with is we add that to the old location, and that's the new location. And we keep doing that again and again and again and again and again. Okay? So what I'm doing here is every tick, that's when the game updates. Okay? And in this situation, what I'm going to do is quite simply, I'm going to say to this thing, every tick to add, I'm going to get the sun, which I've just dragged in. Okay? I want to get the sun and I want to add local rotation. And it's going to say, well, how much rotation do I add each tick? And I'm going to say to it, I want to add, now remember, we want to know the speed something was moving at. Oops, sorry, I wasn't sharing the screen. We want to get the speed something was moving at, and we want to multiply it against the time that it's been. Now, the time that it's been since its last tick is known as delta seconds. Okay, so if I was to multiply this, which says, hey, it's been maybe a half a second since we last ticked, maybe 33 milliseconds, etc., that will then add this, okay? So I'm going to multiply this by 10 as a set speed, and I'm going to add this, I'm splitting that inputs to only give me the pitch, okay? Now, with that kind of set up, I'm going to come back here, and what I'm actually going to do is I'm going to simulate this in the world. And you can see here that we've just created a dynamic time of day. And now I'm just going to have to chill here for a little while as the sun circles around the Earth. It sounds like I'm being way deeper, but you know, we've literally created a sun to circle around our own virtual Earth. So we'll just give this a minute. And we're here. For someone that's asking why I don't hit Control S, it's because in UE3, Control S was add subtractive brush. And I spent many, many years getting out of the habit of ever hitting Control S while inside of Unreal Engine. And as such, I'm still terrified to this day of doing so. But as you can see, we just created like a simple dynamic time of day. And the cool part here is if I was to run it and look at the BP time of day, I can actually tell it to look at what's going on inside the scene. And I can see that every tick, it's adding local rotation. This is just running through there. And if I hold my mouse above this, I can actually see the current value that's being added to this every single time. Someone pointed out that it does feel nice to click the giant save button. Correct. So, as I said, you know, we've got this set up. And we can see that we're actually able to kind of create our own little mini time of day system. Now, this is the start of, you know, having something that's really valuable, I think, to team members. Because let's look at how we could extend this, okay? You know, we've got this ticking and we're adding rotation, but what if instead of multiplying this by an arbitrary number of 10, I made this a variable? So I'm going to promote this to a variable. And I'm going to call this sun speed. Okay. Now, what I've just done here is I've created a variable called sun speed, and its value is set to 10. All right, that's kind of useful, but if you click on this little eyeball and it opens its eye, and we go back into the world and we look at the time of day actor, you can now see that over here in the details panel, we have a value called sun speed. So what's really useful about this is if I set the sun speed to -10 and hit play, the sun's now going to go the other direction. Or if I wanted to, I could set this to -40 and we'll have a much faster sun. Give just a second. So as you can see, we're kind of like able to now drive certain values through these extra variables. Some folks have said they're getting low resolution. If you are getting a low resolution, just make sure that your the stream itself is set to 1080p. Every now and then, YouTube will default to 144, and it'll get pretty blocky. So if you're seeing that, just make sure your stream is set to 1080p. If that's not working, then let me know and I can begin panicking. So we see here that we've created ourselves a pretty basic setup here, but I hope I'm kind of starting to illustrate what's going on and why this is useful. Now, someone asked here, can you lock it to an FPS? Yeah, of course you can. Another way that you could potentially do this is you could literally get the current game time. So you can actually get the time of day. So if we wanted to, instead of adding rotation each time, we could look at the current time in the world. We could have a variable that's always ticking and tracking that. And we could say, hey, set it to be that divided by a number. That way we could easily just have a scrub to change it through to 10 a.m. or 10 p.m., etc., etc. Now, it's worth noting for some of the film folks that and architectural folks that may be here, that we actually do, like I'm showing you this as a... what's it called? I thought it was called time of day. I'm showing you this and I'm like, hey, here's how to make your own. But we do have, there it is, the sun position calculator, which you can actually give a date and time and a longitude and latitude, and it will put the sun in the correct position. So like, I'm showing you this purely for demonstrative purposes. I don't expect everyone to go out there and just like smash out their own time of day blueprints as, for their projects. So don't stress too much on that one. You can use something like this, which is really, really valuable, especially if you're like, all right, we're going to be filming this thing here, as previs, and we're going to be filming it on March 7th. Where's the sun going to be when we get there at 10 a.m.? So it's pretty useful to use something like that. So anyway, I'm going to go back to the pretty level, and we're going to start working with blueprints in a different way. Now, to work with blueprints in a slightly different way, I'm going to begin by re-demonstrating something that I showed in the interior environments demo that I gave earlier in the week, which is I'm going to import a pipe. So I've got my folder here with all of my assets in it, and I'm going to import a pipe mesh. Okay. Import. Very, very, very basic. We've got ourselves a pipe, and we've got ourselves a very simple shiny orange material. Okay, so there's nothing particularly fancy about this pipe. The only thing that's worth noting is that it has a ton of like sub-divs running along the length of the pipe. Okay, that's it. Now, what I want to do here is I want to create a tool. Okay, so I want to create a tool that references this pipe. And what I would like to do is create a new blueprint. And once again, we're going to create a blueprint based on actor, because this is something that we're putting in the world. And I'm going to call this BP pipe, BP spline tool. Okay. And if I open BP spline tool and I add component, it's worth noting that I can go ahead and I can add what is called a spline. So see this line here? So let's just go ahead and drop this spline into the world. In hindsight, I should have used that fence, but that's okay. So we've got this spline, and I'm going to alt drag it out and alt drag it out. So every time I click on a point and hold down alt and then drag left click, it allows me to create a new point. Okay? Nothing too fancy. Now the reason I want to do this is back in my spline tool, before we use the event graph, and the event graph was what is happening while the game is running. The construction script is what happens when something is added to the world. So this is really useful because if we wanted to, I could get my spline and I can get all sorts of information from it, such as I could look up the points of any aspect of the spline. I could say, hey, where are each of your points? You know, where is point number 1? Where is point number 2? And what's cool about that is, let's say I wanted to get the location at a random spline point. Okay, this will actually say at this point this is the location. So let's look at spline point 1, which is the second point along, because spline point 0 is the first point, if you know what I mean. And I'm going to just add a static mesh of the pipe. And I'm just going to say to it, add it at that location. And you'll see here that now, at the first point, there's a pipe. And if I go back to here, I can see that at the first point, there is a pipe. Do you see that? Now, what's cool about this is if I wanted to, I can actually say to the spline, I can say, hey, how many points are there? Let's add a pipe to each of them. So I could actually get a for loop, which says between 0 and this number of times, do this thing, and then when you're done, do this thing. Okay? Now, that logic of what I'm discussing here means that I could also say, hey, spline, how many points do you have? Or I could say to the spline, how many segments do you have? And watch what happens. If I get these, and I just plug this single thing in, which tells me the current number that it's up to, this has now added a pipe to each of those points. And if I go back to my stylized kingdom, we now have these rando pipes at each single point, which kind of looks kind of strangely mysterious to me. Who put them there and why? Coming up next on the History Channel. So we've got these in. But what if we wanted to connect those pipes? And this is where things get really cool. Because what if we said, I want to connect this pipe to this point, and this pipe to the next point, and the next point, and the next point. Okay? So in this, with that logic in mind, what we actually do is we don't add a static mesh component because those can't be changed. What we add instead is a spline mesh component. And we just need to tell it, where do you start and where do you end? Now we're going to start at this position and we end at the next point's position. And the next point's position is equal to the current point plus 1. So if we're currently at 1, we want to get the position of point 2. If we're at 3, we want to get the position of point 4. So I plug this in. Okay. Now, oh, I forgot a very important thing. I didn't set the pipe as the mesh. Now, that may look a little strange, but what we're actually seeing here is it's stretching those pipes around. Okay? And a cool thing here is we can actually, so it doesn't know which way to stretch them, so I'm just going to tell them, hey, this pipe is meant to be stretched along its z-axis. And we can see here that we've got a pipe that is stretching its way along the spline. And another really nice aspect of this that we may want to look at is if we get this pipe, which is now stretching along the spline, we've got one little mistake that we actually need to clean up here. This last point is doing something weird. And the reason for that is this point is trying to connect to itself because there's no point after it. So I actually need to tell the last point to not do anything. And to do that, I'm just going to say, hey, -1. And then we're good. And the cool part is, you know, at any point I can click on this and I can alt drag. And I can alt drag. And we could set this up. And we could have our own little asset, which is pretty wonderful in my opinion. But one of the other really nice aspects of this is, what if we set some of these things up as variables? So if I went back to my spline tool, here, where we set the spline mesh component and all of its information, what if I set the static mesh? Now this is going to be something that we actually want to save to a variable, much the same way as we had with the sun speed before. So I'm going to call this mesh. And I'm going to expose it. And I'm going to set the default to be the pipe. I'm going to plug that in. Now this is going to get a little bit cluttered because I'm going to have, you know, lines going everywhere. There's a very easy way to avoid that, and that is, you know, for things like this, if I double click, I can add what's called a reroute node, which just gives you a little point from that position. And if I wanted to, I could also save things off as variables. So I could right click on this and save it as a variable called current spline mesh. And save that. And at any point, I could just look that up instead. So this will look a little bit cleaner in just one moment's time. Oh, sorry, I wanted that bit connected. So as I said, like by plugging these things in here, we go back. Here's the cool thing. If I was to put in a new one, so if I was to put in a couple of things here, let's say I wanted to get this fence. I have no idea, by the way, if what I'm about to do is going to work, so YOLO. But we're going to click on that, select this, and change it to a fence. Technically, that worked. So we could actually switch this mesh with anything else that we wanted. It's pushing it down the wrong axes, mind you, so we're going to need to change that one next. But it is still working. So I'm going to select that, and I'm going to say, hey, well, let's make the axes, because remember I changed it to Z before. Let's make the axes a variable too. So all I need to do is, once again, you know, just kind of look at this, and the current spline mesh, set the forward axes. Okay, and this will also be a variable. So the pipe is Z and the fence is X. All right, that works way better than expected. Just going to keep that in mind for the future. By the way, the key that I just pressed was end, which will automatically drop something to the floor. But now I could get this fence and I could be like, hey, let's bend the fence over to here. Or let's bend this over to here. So instead of having to come up with my own meshes here, I could kind of lay down some basics. So to keep people out of this pipeline that I just set up. There you go. Just invented a narrative. So, you know, I can copy this as many times as I need. I can delete this. I can stretch this off that way, etc., etc. Don't ask me why this is going to here. It just is. It's going into the ocean. Hashtag environmental storytelling. Look at that. So we've got ourselves something basic here, but hopefully you can kind of see the benefits in doing something this way. You know, like an artist could just knock this together, especially once you've done it once or twice. You know, like if you've done this before and you've got a good feeling for like how this is meant to work, nothing is going to stop you from then just kind of making these yourself from then on in. Oops, sorry. I Windows dragged instead of Alt dragging. So hopefully people can kind of see some of the benefit there as to why I would want something like this and why I would want to set something up, why that's useful, etc., etc. It's also worth noting that like these things can have collision as well. Nothing stops that. So, oops, I broke lighting. Movable. So nothing stops these pipes from having collision. If you want to do that, you literally just need to select the asset, and when we add the mesh, it's no collision. Tell it that it now has collision, and now things can run into it and it can stop them and things like that. Okay, so hopefully you can see some advantage. Some said if you don't plan on making tools in Blueprint, is there any performance advantage instead of building them in the level? That's a great question. You will have a performance advantage, you know, if these are baked out as a single mesh. So, you know, if I wanted to click on this and like have that as a single mesh, yes, you'll have a slight performance advantage. Especially if you're using a lot of them. But it's worth noting that Unreal Engine lets you actually use the mesh merge tool, which is, sorry, it's under here. There is actually a mesh merge tool, which is somewhere around here. I think it's right in front of me and I'm just not seeing it. That allows you to actually kind of bake these down to a static mesh yourself. You can also actually call that in Blueprint to kind of bake these down yourself. The difference here is that by doing this, you've just got way more control. You know what I mean? Like as you're filming it, you're like, actually, this needs to be here. You're not now pushing something out to Maya and then waiting for it to be fixed there, tweaked, re-imported, tested, assessed, and potentially altered again and again before everyone is happy. So you know, the more you're able to kind of minimize that, the better, in my opinion. So hopefully that kind of answers that question. Have we had any other questions pop up, Alex, that are good ones for this section?
So far, I think we've been covering them, but yeah, just the performance effect. I may as well add on a little bit as, like for example, for these construction scripts, they only run when they've been modified. So in editor, they'll run again when you press play, and that's it. And then it's the renderer cost. So in this case, you've got multiple static meshes or spline meshes. So you're getting draw calls from there, and that will chew a little bit of CPU. But
one of the questions I had was about making the fences straight so that they don't curve. That's a great question. You can right click on them, and you can set them to linear, at which point this next point will now be straight. So if I wanted to straighten this one out as well, I could just go, hey, linear. And that, oops. And that's getting bent by that still. But yeah, so you can kind of set that kind of functionality up. I'd need to, I think because this one is also, she's doing it. Or maybe it's constant. My bad. Anyway, so yeah, you can actually straighten these up quite a lot. You just need to have the ones around them, I think, doing it. Yeah, constant is the one for it. So hopefully that kind of helps that out. Someone said, can you make the whole spline linear? Yep. You could. It's probably easy to have a checkbox or something like that in the inside the spline that would do that for you. Cool. So next up, we've kind of gone through. We've added some basic aspects there. What I would like to do is I would like to set up some scripting for a character. Okay. So I'm going to go to here and I'm going to start importing some stuff. I'm going to create a new folder called Night. And I'm going to drag in some stuff from that. Okay, so give me 1 second to just open up the folder. So this time I'm going to import a sk_night character. Now this character was taken from an older demo that Epic had. Unfortunately, it's not available in the Learn tab anymore. So it's kind of It's not a legacy sample. But that change happened reasonably recently, so I'm not sure if it will come back or what the deal is. But either way, it's just a simple character for testing. So I'm going to import this. I'm going to tell it that I don't want it to import materials. Yeah, actually, I'll create a single new material. And I'm going to click import. Now, whenever you import a character into Unreal, you're going to get 4 things. Well, at least 3. First is the skeleton. Okay, so the skeleton is all of the bones. Now, the next thing you're going to get is the skeletal mesh. Now, the skeletal mesh refers to the actual polys that are like attached to that skeleton. And you can have multiple skeletal meshes to a single skeleton. Okay? And then finally, you're going to have the physics asset. And if you told it to, you're going to get a material for the player as well. Now, the physics asset is kind of simplified collision for the character. And it means that it's auto-generated, but it means if I do things like hit simulate, she's going to fall down and collapse as appropriate. Okay, and you can tweak these and set this up yourself as you see fit. Now, I'm also going to import a couple of textures for this character. I'm going to get her diffuse, her masks, and her normals. Drag them in. So that's those 3 textures. And while I'm at it, I'm also going to go ahead and I'm going to bring in a bunch of her animations. And drag these into. Cool. And we're going to tell the animations that we want to import them for the skeleton. And now we're going to chill for just a second. Cool, and now they're in. Now, the first thing I want to be able to do is I want to set up the character to have some textures. Okay, so I've opened up her material, and I'm actually just going to select the 3 textures that I imported, and I'm just going to drag them into her material. I'm going to plug her diffuse into her diffuse. I'm going to plug her normal map into her normal. And you'll notice that it's currently representing her as a sphere, and she is notably not a sphere. To fix that, all you have to do is select the character here, and then select this little teapot, and it will set the current selected mesh as the preview mesh. So give it just a second, it'll catch up. And we can see here that we've got the character. Now, that's her base, super simple setup. Let's have a really quick look at what that looks like. Just gonna get that and just drag it into the game. That looks okay. She's doing all right. All right, great. So we've got her kind of set up in a rather simple way. But what I would like to do is I would like to control the color of her hair. And you'll notice before I imported an extra texture that was a mask texture. Now, a mask texture is literally someone has gone through and they've just painted a bunch of different colors to different regions of this character. So we can see here that green is her hair, blue is her eyes, and red her armor, specifically the metal parts of her armor. Now, what's really cool about that is we can use that information to do things. For instance, if I wanted to, I could get the green channel, and I could let's take a look at what that looks like. So if I just look at the green channel of that texture, what I'm going to see is white wherever her hair is and black wherever she has no hair. Okay? And the reason for that is the green channel represents 0 as nothing and 1 as something. Okay? Well, it's all the way something, I should say. Now, the reason that's really useful is that if we drop in a node called a lerp, what a lerp does is when something is a value of 0, it will be equal to A. And when something is a value of 1, it will be equal to whatever is plugged into B. So I'm going to tell it, hey, whenever it's not hair, just show what you normally show. But whenever it is hair, I'm going to make a new thing called hair color. And we're just going to set a... If anyone in the chat has a color preference, it's going to be a 10-second lag on that question, but let's set that up. 10-second lag, and then someone says the word blue. So you can see here that we're now able to click this, and I can be like, hey, what do you look like with blue hair? Let's go for that. It's like, all right, everybody chill. So we can now set this up, and we've got a character that we can actually see what's going on with here. Okay, so we've got her with blue hair now, courtesy of D Kindness. And we can see that, you know, we've got the basics of a character kind of going here. And one of the really cool things that we can do with this as well is I could use some of these other channels to do some interesting stuff inside of Unreal's pipeline. For instance, when we looked at this before, we saw that red represented her armor. It represented all of the metal on her. And what that means is if I wanted to use PBR, and it's worth noting that physically based rendering might look a little bit strange in this environment, but I'll plug it in anyway. I could tell red channel to represent metallic, because it's going to be 1 wherever there's metal and 0 wherever there's not. And we can now see that her armor has gotten just slightly more metallic in those areas. And if I wanted to go all the way on this, I could actually tell it that whenever there is metal, have a very low roughness, and whenever there is no metal, have a very high roughness. Give that just a second. And you can now see that her armor is actually acting a little bit more like armor. Now, obviously, that's not going to fit our aesthetic particularly well. Someone said, any advantage over doing all this lerping instead of just having different material channels on the model? Yeah, so the advantage of this is just tighter controls, right? You know, you can tweak this in the scene without having to have texture imports going all over the place. And as well as that, you just save a lot of memory. So, you know, if you're going to have certain things fed off of other variables in certain ways, you may want to just bake out some cleaner mask textures and then project metal onto her body and use the same metal that's projected onto her body in 50 different characters to keep the overall cost of the scene down. So if we go back to her in the world, who has since been deleted. She's not getting any reflections right now because there is no actual reflection environment in the world. And cool. So we can now see that she's properly reflecting the purple sky and stuff as she runs around. Now, obviously, we made her too reflective, so it looks a little bit strange. So I'm going to actually dial all of that back. It was purely for the sake of kind of illustrating what she would look like there. Cool. So I brought that in. She's reasonably well set up at the moment. Let's go ahead and do something a bit more interesting though, right? So I did all of this setup because I wanted this character to be, in there for me to start working with. Okay, now the way that I'm going to work with this initially is I'm going to create, once again, a new blueprint class. Okay, so in the same way that I had a blueprint before that was an actor, this time I actually want to have extra stuff in there. So instead of creating an actor, I'm going to create a character. I'm going to call this night character. Okay, now a character is a type of actor that has all of the information involved in it to be a standard bipedal creature, which is really, really useful. So it has a lot of stuff built in for AI, it has a lot of stuff built in for movement, it has You'll see. I'm going to open this knight character, and I can see that it's already actually got a capsule component and an arrow component and a mesh component that doesn't have one set, as well as a character movement component. Now, what's really great about this is that if I was to go to my skeletal mesh, I can just set it, and I'm going to plug her in so that she's here and facing that way. And I'm going to, the capsule component represents an approximation of her size, so I'm going to shrink that down because she's a bit smaller than what we have there. Cool. And I'm going to drop the mesh down a little bit as well. How are we going for time at the moment, Alex?
You're about 45 in?
Wonderful. Keep it on time. So, I've got that, and if I was to put her in the world, she's not going to look like she's really particularly interesting right now, right? But she's actually got, she's now actually dressed up inside of a blueprint. So what I mean by that is we can make her do all sorts of interesting things. So the first of those is, let's pretend we wanted to change her hair color, okay? If I go back to the character's blueprint, I could actually say in the construction scripts, I want to get the mesh, and I want to set a parameter, on her character. And the parameter I'm going to set, remember we made a value called hair color before? I get hair color. I'll open up the material so we can see it. So I created that value before called hair color that we set to blue. If I wanted to, I could actually get her hair color and make this a random vector. And now, when she's added to the scene, she's going to have a random value. As we move her through the scene, she's going to switch them up to whatever we have. Because every time the construction script reruns, it's randomizing her hair color. Now, another option we could do is, instead of having it random, we could go ahead and make a variable that was called hair color. And we're going to set this variable to be type color. So I'm going to make it a linear color. And we're going to expose it and plug that in. Now watch what this does. I'm now able to select her and say, hey, I want your hair color to be this one. And the character that's next to you, I want you to be this one. That's it. We've got a stew going. All right. So we've got her, and we can kind of set these things up. Now, the next thing that I would like to do is I would like these characters to run through the world. Now, how do we do that? That sounds complicated, right? Well, the cool thing is if we add a thing to the world called a nav mesh bounds, I'm going to drag this in. Oops. Sorry, folks. There. Somehow it ended up all the way up here, and I'm not entirely sure how. There we go. Okay, so we've dragged in a volume called a nav mesh bounds. Now, how a nav mesh bounds works is it automatically, if I hit P for paths, I can see that it's showing me a green box wherever it's touching the ground. Now, let's have a look at this in a slightly wider sense. So I'm going to make this box much bigger. They think they can navigate on water because I haven't set that up to not navigate on. But that's okay. I'm just gonna put the box here just for the sake of illustration. What this is actually doing is it's creating a nav mesh across this area to say, hey, the AI can move in this space. And I can alt drag and connect a few of these together. But this kind of creates a simpler space for the AI to figure out how to move around in. Okay. So anywhere there's green, it knows it can walk at the moment. And this will automatically respond as well. So if I was to get this part of the pipe and be like, hey, I actually want you to be lower and you to also be lower, they now know they can kind of navigate over that space a bit. Okay? Now, what this is doing is this is kind of creating simplified geometry. Now, the reason I might want to do this is if I go to my event graph, I could actually tell the character, hey, when the game begins, I want you to move to a location. And first off, I need to tell it which pawn to move. Now, I've been using the word character so far, okay? Now, I did skip a little bit of a step, and it's important to note. I'm going to switch over to a camera here. All right, so this is going to be a little bit strange, but Unreal has a thing built into it called controllers and pawns and characters. Now, a controller is like the brain. Sometimes it's AI, sometimes it's human. Now, a pawn represents a body. So it represents something that a brain can control. Okay? Now, because of that, you could have a pawn could be a character who has all of their human movements. But a pawn could also be a vehicle. So what that means is, hypothetically, I could be a pawn, and my chair could also be a pawn. And when I move over to it and hit use, my brain would disconnect from my body and connect to my chair, and it would then drive the chair with all of the chair logic attached to it. Okay? Now, the reason I'm bringing this up is because if you are going to do any basic AI to kind of litter your world, this is really useful. Because I'm going to say, hey, the pawn that we want to control is ourself. And the destination, the place that we want to move to, is going to be, we probably want to have some sort of random reachable point, right? So I'm going to type in random reachable point in radius. And I'm going to give it more information. It's going to say, well, a radius around what? And it's going to be my actor's location. And how big is this radius? Well, let's set this radius to be 1,500 units. Okay? And if I was to go back into the world, and I was to look at these two and hit simulate, they both move to a location. Side note, I totally forgot there was sound inside of this project, so if that's very loud, let me know and I'll turn it down. So we can see that they're moving to a location. Okay, so next up, all right, so they're actually able to move to a location, and that's useful. But let's go one step further. Let's have them keep going to new locations again and again and again. Now, what I'm going to do is instead of running AI move to, sorry everybody, you've got if you've got music playing in background and I'm ruining the vibe. I'm going to create a new custom event. So to do that, I created a custom event, and I called it Wander. Okay, so I've made it my own event, and when the game begins, I can now say, hey, start to wander. And whenever you reach a location, I want you to wander. And whenever you fail reaching a location, I still want you to wander. In fact, how about this? Whenever we succeed, what about we chill for a little while? So I'm going to be like, hey, delay for 2 seconds, and then wander again. And now we're going to go back to this. And we can see this working. And so peacefully too. So we've got that all set up. I'll dial back the volume for everybody a little bit. We've got that all set up now, and that's starting to become something that's kind of useful, right? The next thing I would like to fix though is she's kind of T-posing through the world, and that looks a bit weird. So, well, what can we do there? Well, cool thing is we can actually set up what is called an animation blueprint. Okay, so someone said, what happens if they go into the water? Will they follow the water mesh or drown? We haven't added any logic for them to drown, and the water itself is still set up as solid. So right now they could totally walk on water. Okay, so we've got this going on. We've got this set up. What I'm actually going to go through and do next is I want to have her have animation so that as she runs around, she doesn't just float across the world. Okay. Now, we've had a couple of other questions pop up. Someone said, is this random each time? This will be random each time, but you could potentially either store these out ahead of time, or you could you could use a random seed. You would have to use a little bit of C++ to get that working, but let me cover that a little bit later and you'll see. Okay. So anyway, back on track. We've got a character that can kind of, she can float around, but I would love her to be able to run. And because of that, it's time for us to create what is called an animation blueprint. So an animation blueprint is a specialized blueprint that controls how animations stick together. Okay, so I'm going to get that, and I'm going to say, hey, this animation blueprint is based on the night. I'm going to hit OK, and I'm going to call it ABP _ night. Now, this is the animation editor, and this is actually reasonably straightforward. So, so what we want to do from here is we want to set her up with some animations. Now, you'll see here that we have an anim graph and an event graph. So this is very similar to what we've been dealing with to date. If I go to my anim graph, you'll notice I'm able to actually do things like I could grab run forward and I can just connect it, at which point she'll start running. Okay. What I would like to do though is I would like to set up a little bit of logic that can control her so that she runs in the correct way to how this has been set up. So watch this. If instead of plugging in an animation here directly, I created an animation blend space based on a character. Could you call this blend space _ night locomotion? What we actually have is a really cool little thing, and I suspect some of the filmmakers involved will really like this too. And that is that what I can actually do is I can set up rule sets about how these animations are meant to blend together. So what I'm going to do is I'm going to tell her that the right axis, horizontal axis, represents her right movement. And -200 is going to be on the left, and a speed of 200 is going to be on the right. Her vertical axis is going to represent forward movement, where the lowest value is -200, because that's backwards, and the furthest forward value is going to be 200. Now check this out. I'm now able to say when she's moving at a speed of 200 units forward, she's doing this. When she's standing still, she's doing this. But the great thing is it's able to say, well, what happens when she's moving at 100 units? More importantly, if I was to go back to the run, I can then just say, well, here's what happens when she's going backwards. Or left, or right. And if you are using this yourself, it's worth noting you can add little markers so that her feet, if you have animations that don't perfectly line up, you can use sync markers that try and match the animations as well together with one another. So you can actually set down sync markers so that, you know, her steps will blend at the correct point. Okay? Great. So I'm going to hit save, and I'm going to go back to this animation blueprint, and what I'm going to do is I'm going to say, well, let's grab that blend space that we just made. And we can see that it's kind of working, right? She's chilling there, everything's good. And we can actually preview it here as well, like when values eventually get plugged in. But it's not set up yet, okay? Now, the reason that it's not set up yet is I created values called right movement and forward movement, but I never actually defined what those things were. Do you know what I mean? Like I never actually said to it, this is the value that's getting set there. So I need to actually go to the event graph, and I'm going to get the logic of the pawn owner. So I'm basically going to say, when the game runs, I need to find out how fast she's moving. And to find out how fast she's moving, I'm going to get her velocity. Now, her velocity is going to be in world space. So what I mean by that is if she's moving 100 units along the x-axis, she would be moving this way. Okay? But we actually want to find out how fast she's moving relative to herself, which means we need to find out how fast she's moving if x was that way. And when I turn, when x is that way. You know, we need to find out how fast she's moving forwards and right, rather than how fast she's moving through the world relative to its own xy coordinates. So what that means is if I go back to here, I can say get the velocity, but I want you to get this direction and put it in the space of myself. Okay, and I know that was a little bit of just sudden, strange transformation math, but it's the kind of logic that if you know it one time, everything becomes way easier. And I'm going to call this local velocity, because check this out. In the anim graph, I can now say x is forward, y is right. Okay? And back on my character, if I go to her mesh and I tell it to use the animation blueprint that we created, you can see when they're staying still, they're doing that. And when they're running, they're doing that. She can't get past it because she doesn't have a proper step height just yet. So we can see that they're starting to actually work, which is kind of nice. But she still is not kind of turning. She's instantaneously snapping. If you watch her animations right now, if you watch her, she's going to snap direction changes when she turns. There it is. And I would like her to slowly turn towards whatever it is that she needs to face. And to do that, again, is relatively simple. What I need to do is in my class defaults, there's a default setting that's turned on in characters that says use controller's rotation yaw. And what this means is wherever your brain is pointing, make your body point that way as well. And whenever she gets a new location to move to, her brain instantaneously snaps to that. What I would like to do instead is I will turn that off. And now we're going to have a different problem. But let's have a quick look here. So she's now not going to turn at all. But you can see that the strafing is working too. Notice she's actually sidestepping. Okay, so I can see that's kind of working, and we're kind of getting somewhere. What I would like to do though is I would like her to rotate. And the cool part of that is that's actually super easy to set up as well. Like I said, having these kind of like fundamental classes just makes everything easier. Here it is. There's a section here called Use Controller's Desired Rotation. And you can set up her rotation speed, which is just 360 degrees per second right now. And now when we watch her, she should comfortably rotate to the next thing. So the cool part here is that, like, with what we've got going on, you know, we've started to get the basics of something going on. But one of the things that I really, really love about this kind of general setup is we could actually set up a take recorder to capture this into sequencer. So I'm going to hit save, and I'm going to go to cinematics. My take recorder is not there. Oh, I know why. Sorry, folks. One moment. Just quickly turning on tape recorder. In the meantime, Alex, has there been any questions that have come through that have been things that I can help with, or have you been playing whack-a-mole with the YouTube comments this whole time?
I've been playing a bit of whack-a-mole, so I think we're pretty good so far. But if there's any questions in the meantime, feel free to ask.
Cool. There you go. Someone was asking how this applies to. Someone asked how this applies to filmmakers, and they just didn't give me a chance. All right, so I'm going to put this through again. Cool. So again, with what we've been doing, I can now go take recorder. And what's cool about this is I can add each of these characters as things that we want to record. So we could have this set up. Oops, I'm going to put them there. And I'm going to say source. I want to capture the two characters. We're going to hit... And they're going to run around and do their thing. And let's hit stop. Close it down. Now, I did hit record just before I hit play, so I'm not 100% sure if that's going to work, but we should see pretty quick. Yeah, 1 second. Sorry about that, folks. I made the mistake of not hitting play first. So let's do that again. Also, start echo time. Record.
So Luke Williams asks, this is the first time I've been able to jump on live, so hopefully this hasn't been asked already, but can I be set up for AI-driven characters after the tape recorder? Save the movement?
I actually can't hear you past the music that's going through the desktop. Give me just one moment. Cool. Hit stop. Okay. Sorry, give me 1 moment. There we go. So I can now see that I'm actually able to kind of scrub through each of these takes. So the question regarding why is this useful for filmmakers is I can easily set up AI to do what I want. But more importantly than setting up AI, let's look at the next obvious step here, okay? I'm going to close this take recorder down for just a bit. Someone said, or birds, or cars, or anything. Yeah, exactly. So, like, this is really wonderful, because what we could also do is this. What if, okay, let's use our noggins here. What if we got this character and we said to them, I want to actually control you. You know, I want to set you up, and I want to be able to steer you and move you around myself. So check this out. If I go to my project settings and I go to input, I can actually set up a few buttons. I'm going to do axis mappings to begin with. I could say move forward is bound to the W key. And I could say that move backwards is bound to S. So moving forward and moving backwards is the same thing, but backwards is a negative scale. So one is, if it's forward, it's 1. If it's backwards, it's -1. Same thing here. Move right and moving left. So this is going to be D to move right and A to move left. And I'm also going to set up another one for look, which is going to be my my mouse Y, so up and down on my mouse. I'm going to invert it because I want my mouse set up that way, don't judge me. And I'm going to set up one called turn, which would be mouse X, okay? Now, the cool thing is with setting these things up just here, what I'm able to actually do is I can go to this and I can say, move forward. That's now just a thing that exists because I created it in my project settings. And whenever I want to move forward, I want to add movement input. And the direction that we want to move in is going to be my actor's forward direction. And that's it. Because now I can go move right. Add movement input. And the direction that I want to move in is my right vector. Okay. And the last bit that I'm going to do is I need to be able to look, which is add pitch. And I need to turn, which is lowercase and killing me, but we'll struggle on. Okay, so with these things set up, check this out. I can now have them all plugged in. I can hit save. And if I was to, I'm going to create a third character so that I have some sisters running around me. It's not just me. I can select this and I can actually say, hey, I want to possess this. Now, what this does is this means instead of sticking the AI into it, I can say, I want to be this character. And if I hit play, I'm now able to pilot it. If I want to have slightly better controls, or I want to add a camera that down the track the camera is actually able to follow in sequencer, I'm actually able to go all the way out and add a camera. Oops, I did a cine camera, which is I added a cine camera. I might make this one a regular camera just because that's a bit more gamey. Now the cool thing is again, like I can get that, and I'm just gonna use the rotation there. There you go. So that's her. She's now able to kind of run around the world. We're all set up. And the fun thing is I could actually record my own movements into sequencer. Okay, so the advantage of me being able to move my own movements into sequencer is that I'm able to actually set up, like I could be a car and drive and make all sorts of cool turns, use take recorder to record it, and then I could be 10 different take cars because I can play the sequencer back while I'm acting in it. So I could then play this back 10 times and have 10 different cars chasing me that are all looking cool, but they're all actually still just me. Do you know what I mean? Or I could set up using motion capture if I wanted to. I could be a person firing off into the distance, and then I could be the zombie that I'm firing at, and then I could be 10 other zombies that I'm firing at, and then I could use take recorder to retake the first person that was firing, and now have a more accurate idea of where I'm meant to be shooting because I'd shoot at those zombies. I'm coming up with arbitrary reasoning here, but what I'm trying to get at is you're working in real time, and we can leverage that to its maximum extent. And I think that's super exciting. You know, like we can really cut a lot of corners in getting things up and running quickly. So I hope this is kind of I know it may have seemed weird at the start how I was like, all right, let's set up a character to do some stuff. But, you know, I mean, we could do the same thing. We could do the same thing to, you know, have additional actions, right? So I could actually play as the character and I could bind spacebar to jump, or I could have, you know, whenever I hit Z, she'll do a victory dance or whatever. And then I can bring that into Sequencer, adjust it, and blend in my own animations. But I could have like a full robust track that I then just use as the starting point to lay down all my cameras and to block out the scene, and then set things up correctly beyond that and tweaking on a per shot basis. And I think that logic for certain kinds of projects, obviously not all, but for certain kind of projects, I think that logic and that foundation that you can build from is a really, really, really exciting prospect. And it was something that, while it may not seem super related when I first went into it, I hope everyone here can kind of see why that's pretty powerful. Now, the last thing I'm going to do before I hand it over to Alex, I know I've been chewing up all his time, but the last thing I'm going to do is I'm going to go to Input, and I'm going to add an action mapping that is bound. It's going to be called Jump. And I'm going to bind this to spacebar. Okay? And I'm back in this character, literally going to say, whenever they hit jump, jump, because that's just built in. Okay. Now, with that set up, if I go back, she's now jumping. But you'll notice her animations don't look particularly great. And the reason for that is we haven't actually set up any logic in her animation blueprint to deal with what happens when someone moves through the world. So what I'm actually going to do here is I'm going to create a state machine. And I'm going to call this basic locomotion. I'm going to cut what I've already got and plug this in. I'm going to open up my state machine. Now, state machines allow me to make states. So I could say walking and idle. And I could then have start jump. Okay, make another one, jump. Landing. So, and then able to kind of set these up as I see fit. So whenever she's walking and doing her normal thing, let's tell her that she's walking and doing her normal thing. Whenever she's starting to jump, I'm going to play player jump up, which is just another animation that I have tucked away. I'm going to move through, and whenever she's jumping, like so she's already in the jump, I'm going to play her falling animation. I'm going to tell that one not to loop, and I'm going to make sure I tell this one not to loop as well, so turning off looping. And whenever she's landing, she does have a land. There it is. Cool. And now all we need to do is set up the logic of like how we kind of work through these things. I'm gonna get this, and I'm gonna say walking and idle. So to determine whether she's jumping or not, we need to determine whether she's falling. And back in my event graph, what I'm actually gonna do is I'm gonna get my pawn, and I'm gonna see if it's a character. And that's, to do that, we do a technique known as casting. So this just says, is the thing that's plugged into here a character? And the reason I've done that is because characters have a nice little thing called is falling, which I'm going to save as a value called is falling. Now I'm going through this part pretty quickly because it's more important to me that you just generally understand that this is something you can do, and you kind of go through the tutorials yourself to kind of get that going. But to say whether she can jump or not, all I need to do is say, if you're falling, consider yourself at the start of a jump. To say whether she should go from jumping to her falling animation, all I need to say is if the time remaining on your jump up animation is less than, I don't know, like your crossfade duration, allow it to do it. For landing, I'm literally going to say if is falling is not true. And finally, to say whether she can walk again, I'm going to say if the crossfade and the land animation, time remaining on the land animation, if that is less than or equal to her crossfade duration. Check this. And that's it. So, like I said, like I know I breezed through that pretty quickly there. The crossfade durations, by the way, the values that I'm using here are literally set up. If you click on any of these, there's a little value there called duration, which is super useful. So hopefully that's valuable. Hopefully people can kind of, you can see where this is going, because you can record all these things back to Sequencer. You can actually feed information from Sequencer into an animation blueprint as well. And what that means is you actually can set up in Sequencer certain blend rules that you can then just trigger in the animation blueprint. And that's really, really valuable, again, for saving time, so you don't have to like hand animate all of the state transitions and warps between certain things. So being able to leverage that is incredibly powerful. And I'd say with that, we've probably finished up my section, Alex. It's time to handball this one over to you.
Hey, excellent.
Okay.
Well, excited to do this. Finally, I get my time to shine.
You finally get time to shine. Alex builds. Give me just 1 second. Do you mind setting up your stream for me?
Yeah, sure.
Right, give me 1 second. All right. And we are back to my gnarly realistic demo from earlier.
Hey, yeah, so this looks familiar. Hey.
Just like
cool.
old times.
So, hey guys, so I'm Alex. You probably haven't heard my voice too much, but you've obviously seen me in the stream chat. My background, as Chris said, is mostly engineering, so I don't do a lot of pretty stuff, so I'm sorry to burst your bubble before I get started. But what we're going to do today is a bit of scripting of tools in the editor. So what a lot of people don't realize is that the editor has a bit of functionality that lets you extend it, like making little widgets and toolbars and stuff like that you can dock around the place and use them to help you improve your workflow. But also being able to influence the world using these tools. So, for example, today what we're going to be doing is we're going to create a few very, very simple tools that allow you to just select objects in a scene and then eventually scatter them around the environment. So without further ado, let's go into it. So this functionality extends upon blueprints, but it's in a very particular editor context. So normally the stuff that Chris was going over was for in-game when you press play and it runs in the actual environment. Whereas the stuff that I'm going to be going over is all about the editor functionality, adding UI and just little shortcuts that make your life a lot easier. So, for example, that functionality is implemented via editor utility blueprints. So you can right-click, go to editor utilities, editor utility blueprint, and you'll be greeted with this little section that shows you all of the different types.
Hey Alex, sorry. Yeah. Just before we go on, is there any way you could drop it from 4K to 1080p? You have very, very difficult to read blueprint icons there.
Okay, give me 1 tick. Is that a little bit better?
That is way better. Thank you very much.
Excellent. Sorry, guys. I keep running 4K and forgetting to reset it to 1080. But anyway, let's do that again. So editor utilities, editor utility blueprint. You'll be greeted by these classes. So don't be scared. Classes are kind of like templates. They're kind of like a way to define functionality and reuse them, or even extend them. So in this case, we're actually going to extend them. So when you hover over these classes, they'll usually give you a little bit of description, like information about what they're used for. So there's quite a lot of stuff like being able to create a specific utility actor, which can be used for just spawning into the world and never being saved into your environment, which is pretty cool. So you could throw them around the environment and use another tool to move them around and use them to say, hey, from point A to point B, create another actor or something like that, right? And there's quite a lot here. Don't be scared about it. What we're going to be focusing on is actor action utilities. And what this does is when we create it, what we'll do is we'll be using it to essentially add a context menu. So whenever you right click on an actor, you can see a little menu that pops up that says do something to this actor, or even potentially many actors. So instead, what we're going to do is we're going to create a bit of functionality to select all actors of a particular type. So an actor is obviously an object in the scene, as Chris has mentioned. And what we're going to do is we're going to say, if we select on this decal, I want to select all of the decals in the scene all at once, right? But nothing else. Or if I select one of these sequences, I want to right click, select all, and it will select all of the sequences. And you can do this by going into and creating your own actor action utility, adding a custom event. We'll call it select actors of type. And there's this fancy, when we select the event, there's this fancy little colon editor checkbox. We're going to tick that. And what this does is it tells the editor, hey, this is something that I want to expose to the editor and to add to our little context menu when we right click on the actor. So when I've added this now, what we can do is we can right click on an actor now, and you'll see this little scripted actions, and you'll see selected actors of type. So you can start seeing that once we click this, nothing happens, right? We have to give it a bit of functionality. And this is the power of blueprints, right? The same tools that we use for runtime, for making your shots be a little bit more dynamic without you having to keyframe absolutely everything. You use that same functionality to extend and modify the editor and to make your lives a hell of a lot easier. Because one thing that is very different in runtime engines is just the ability for scripting. Like, I mean, if anyone here uses Houdini, they'll understand that concept quite a lot. And the concept's quite the same in Unreal Engine. So what we're going to do is we're going to go through and we're going to say get selected actors or get selected level actors. And what we'll do here, this node kind of understands that whatever I've got selected in this environment, it will then collate them into a list that we call array in the engine. And then it'll return this array, and we can do a for loop over this, which just iterates over that list. And what I mean by iterate is it'll just step through each one of those actors and allow us to do something to it. So for the for loop, what we're going to do is we are going to say, actually, firstly, I'm not going to do that. I'm going to check how long that array is, because we only want to do something if there is something or some work to be done. So let's check how many actors are in this list. We'll do a branch, which is essentially like, if true, do this, and if false, do this. So we've got something in the list. So let's do something. We're going to say get a copy of the very first item of the list. And this is going to be a little bit weird. Most people would think, oh, I want to get the first item, right? And they put 1 in the list. Unfortunately, we can't like programmers in Unreal Engine. So 0 is actually the first element in the list, and length of 0 means there's no elements in the list. So you count 0 for the first item, 1 for the second item, 3, and so on forth, and so on. So what we're going to do is we are going to get class, and class is like what I said, that template. So for example, a class for this environment be a static mesh actor here. So you can select, when I select this, you can see that this guy is, if it shows up, usually shows it up the top. Or actually, if I right click it, there is a hint down below. Here we go. Static mesh actor just here. Even in the world outliner, it will say the class of that actor. If I select a decal, you can see decal actor. And so when I call this function, it will return that type. And so what I can do with that type is I can say get all actors of class. So we can get every single actor in this environment that is of the class that we first selected. So if I've selected this first, it will search for something that's a decal actor. If I select a static mesh, it'll select all static mesh actors in this environment. Now you may see this world context object pin. So this is a little bit of that editor versus runtime side of things, right? So in Unreal Engine, we've got this concept of game and editor. Chris was working completely in game before, except for construction scripts, I might add. But construction scripts kind of work in the world of game. In our case, we're working completely in the editor world. And we can actually provide this world to the get all actors class so that we can iterate through this environment here. So in this case, what we're going to do is search get editor world. And you can see this concept of get game world and get editor world. And in our case, we're not pressing the play button. So play button being play in editor, or Alt P is the shortcut, like what Chris was doing. Instead, what we're going to do is going to get editor world. We'll put him back here. And what we're going to do is provide all of the actors of class. And then we're going to tell the editor select. So we're going to set the selected level actors to be the ones of all of these types.
Now, it's worth noting that this functionality that Alex has done so far is actually already built into the engine as a current click, but we're doing this as a demonstration. We're doing this as a demonstration to illustrate how to start building your own functionality and some potential extensions of that functionality that may be useful in set dressing your own scenes. So I know this can seem a little bit strange right now, but the truth is you only need 1 or 2 people in the team who can do this kind of stuff to, shave 5, 10, 20 minutes a day, up to a couple of hours a day, depending on the kind of stuff, from everyone else's workloads.
Yeah. And yeah, as Chris was saying, there is already functionality for this. You can go into select all, or Control A. Select all decal actors, Control Shift A. That'll do the exact same functionality as me implementing this select actors of type. So we can see that we're selecting everything now based on the first one. So if I select the level sequence actor and I go select actors of type, you can see that both of these are highlighted. But what happens if we go one step further? What happens if I don't want to show or select these actors behind my camera? What happens if I only want to show the ones that are in my field of view, right? What we're going to do is a little bit of math, and I hear the groans from here. There is a bit of math, but it's quite simple, So what I'm going to do is I actually answered one of these questions. I think it was Andrew mentioned, is there a way to collapse the nodes or make them a little bit more groups so that I can use them a lot easier? There actually is. If you, it's a quick little shortcut, but you can select a bunch of nodes like so, right-click it, and you can collapse it to function or macro or just the collapse nodes here. Instead, what I'm going to do is collapse to function. I'm going to call it select actors. And the reason why I'm going to do this is because I'm actually going to reuse this function. And this is actually quite a useful thing to do, because obviously I don't want to have to, like, I could go here and say, all right, let's copy paste it. But then maybe later on I go, actually, I really don't want to use like index 0, I'll use index 1 or some random index in the middle, or maybe I'll even randomize it like so. Instead, using a function, I can just modify this one function and then use it everywhere else. And whenever I modify the contents of that function, it will propagate to every other usage of that function. So what I'm going to do instead now is we want to iterate through all of those selected actors of type and check if they're within my field of view. So in here, what we're going to do is we're going to go in, we'll create another function, and we'll say select actors in FOV. Make sure that this colon editor checkbox is ticked. We're going to recall select actors, because this is just an extension on what we're already doing. And I'm going to do a for loop over this. So I will go through each returned actor of that specific type. And I'm going to check if this actor location is in front of my camera's field of view. Now there's this special node that's get level viewport camera info. And as you can see, it'll provide me a camera location and a camera rotation. And this, when I'm flying around, that node in editor context or in the editor utility blueprint will provide me with this camera that I'm shaking right now, its position. So what we're going to do is we're going to say find angle, what's it called again?
It's not fine.
Unit vector. Get unit vector from to our actor location. So what this does is it gives us just a direction. So if you don't know what a vector is, it's basically like an object that, or like a Cartesian coordinate that says point in this direction. It's of a single unit length, and it basically says in this direction, this is where I'm pointing from the camera, or from the camera to the actor. So if actually,
mind if I explain this one?
Yeah, sure.
You got it. I've had to explain this to a bunch of people.
Yeah.
So I mean, what I would do, I've just looked over Alex. So if you imagine that this direction is X, this direction is Y, and this direction is Z. If something is upwards, it's going to be a value of 0, 0, 1, because X, Y, Z, and therefore it's pointing upwards 1. If something is towards the X, then it's going to be a value of 1, 0, 0, which means it's going to be pointing down the X. If something's on Y, it'll be 0, 1, 0. And what this actually means is that if we're halfway between these two, like say between Z and Y, it will be a value of 0, because we're 0 along the X, 0.5 and 0.5, and pointing as an angle along that way. Oh, sorry, not 0.5, 0.5, it'd be 0. It'd be the normalized of that.
Yeah. So in this case, what we're doing is returning that unit vector that is pointing from our camera. So I'll move this just to make it a little bit more clear. It's moving from our camera to the actor. So it will just give me, like, imagine a stick pointing towards that object, right? And then what we're going to do is a little bit of math that gets us the forward vector of our camera. So imagine I'm looking straight at you and there's an object this way. We've got the camera's rotation is a vector pointing directly to you out there. And then the other object might be over here, right? So there's an object. I can't hold three things at once, so you're just going to have to bear with me here. But you've got a second vector that's pointing out here. And what we want to do is we want to get the angle between here and then compare that to my camera's field of view. So if you see that this angle in between here is less than the camera's field of view, we know that we're looking at it, right? So we're going to calculate that angle using something called a dot product. Now, this doesn't give you the angle directly. It's what's called a scalar angle. So it's basically from -1 to 1. And instead, what we're going to do is we're going to use a bit of trigonometry. I know I'm bringing you guys back to, you're all back to year 12 maths, or actually maybe even year 10 for some people. And we're going to retrieve the actual angle itself. And what we'll do is we'll compare that angle with our with the half angle of our field of view, because our field of view of the camera in here is 90 degrees, but that includes the whole frustum, right? Instead, what we want to do is we want to calculate the angle between here, because the dot product only tells us an angle in a positive direction if it's in front of us, or negative if it's behind us, but it only tells us left or right, but nothing, everything in between. So in this case, what we're going to do, instead of 90 degrees, we'll use half of 90. And if it's there, sorry. If it's less than that, what we're going to do is we want to select these actors like we did here, right? However, we've now split off, we need to provide an array, and we're now trying to filter this array. So we need to have a second array that sets these, or we populate with actors that satisfy this condition, right? So what we're going to do is we're going to create a local variable, and this only lives here. It doesn't live in the actual blueprint graph itself. It only lives in the context of this function that we're using. And we're going to call it selected actors. And when this loop is completed, we'll use this array to select our level actors. But we'll also, on the loop, if we've satisfied this condition, we will add the actor that's in our frustum to that array. We'll compile that, we'll save that, and now you'll see that in my scripted actions, I've got note that by default in editor utility blueprints, you'll see that there is the function that I've used for, or I've collapsed. And this has the colon editor checkbox automatically enabled. So we can actually select that and just uncheck that guy. And it will no longer show up in the list. But now we've got our selected actors in field of view, right? So when I select this, notice that all of these decals behind us and around us don't get selected, only the ones that were in front of us. So I'll select this decal just here, and we'll notice that this guy is a decal as well. we'll try it again, just to prove my point. And that decal isn't selected at all. Neither is the one behind or the ones on the right. So this is pretty cool, right? So this is not the only thing that you can do with editor utility blueprints. I've seen clients out in the world who have used editor utility blueprints to do some cool stuff like spinning up sequencer renders, even recording stuff before they knew about Take Recorder and a couple of other things. But it's once you get a handle of just blueprints in general, it opens up so many doors for improving your lives with workflow. Because if you're doing a lot of repetitive things, it might be worthwhile just investigating editor utility blueprints and playing around, because you may just save a ton of time. Now, I did, yes. So Scott Squires asks, I'll do a few questions. Is there a collection of commonly used blueprint snippets? So yes, there actually is. I actually answered this earlier on. They are called blueprint function libraries. So if we go to a blueprint class, actually, sorry, right-click blueprints, you'll see this blueprint function library. And we can call this our library. And what it does is it provides you a way to create functions without a graph. But these functions can be called from anywhere, any other blueprint in the project. So for example, I can say, let's print hello world. And in here, we can just say print string, then hello world. And in here, if we want, we could, let's just for fun, add another custom event, and we'll call it print hello. We'll enable call in editor, and we'll say print hello world. And see how it's already added in to the context menu, print hello world function. We can quickly get to this, actually. Yep. Sorry, we have to add a get editor world. Anytime you see a world context, you can just type world after dragging off of it, and it'll show you those guys really quickly. And from here, now we can just click anywhere. We could call it, and it'll print hello world. And that's how you use reusable functions in blueprints. Bit of a segue, but pretty cool. All right, so this is editor utility blueprints for actions of actors. You can also create actions for assets. So if you create another editor utility blueprint here, there is an asset action utility. And the same deal goes with it. So asset action, we can go in, do a custom event like so, print something, call in editor, and we'll do just another print. Here's an asset. Get editor world. And in here, if we select another asset out there, you'll see print something in scripted actions. And this is how you can use editor utility blueprints for not just actors in an environment, but you could do import pipelines, you could do touch-ups for things, you could spin off stuff like merging meshes using some of the plugins that are already in the engine. And you can start automating quite a lot of stuff. I've seen some people generating collision in bulk using these scripted actions for assets on static meshes. And it's pretty cool. But it's not the only thing, because obviously many of these don't give you UI. So first off, because this is a little easier than the next thing that I'm going to jump in, but you can actually provide an input to these. So is this true? I'll call this, print it out to our print string. And whenever you put a parameter or an input parameter onto our event or function, and you call that function from our scripted actions, it will pop up with a little UI that asks you, hey, fill out this stuff. So this is another way that you can jump in and just provide a quick little UI and then do something, right? It's just a, hey, configure, do something, configure, do something. And whatever that do something will do will take that data and then do something with it. So in this case, we're just printing true, right? Or if I go in, print something and it's false, it will print false, right? Pretty easy, right? What happens if we wanted to make some pretty UI that isn't just a list of settings or something like that, right? What happens if we want to make a custom button or multiple buttons, or maybe even render something that's happening in the environment? Like maybe you want to generate some landscape. This was a demo that we did at NZGDC last year, where we made some UI in blueprints that would show up and you could randomize a height map for landscape. If you saw Chris's landscape stream, it already is in the engine there, but you could make your own tool and customize that and use materials to generate it, and then press the bake to landscape button in your own little editor widget. So what we're going to do is we're going to create something called an editor utility widget. Sorry, I've got to get to a blank. Here we go. So editor utility widget. And what this is it will use something called UMG, Unreal Motion Graphics. And Unreal Motion Graphics is what you see is what you get editor. So for example, I can drag in a button, I can give it some text, right? I can call that text Alex's shiny button, and it's quite cool, right? I'll size that to content so it fills in, and you could do something with this, right? So if I right-click that asset and call run editor utility widget, suddenly we've got it here. I haven't set the anchors, so obviously it's a little bit offset, but now we've got this fancy little button, right? And we could do something else with this fancy little button. We could say, ooh, what's a good example? Let's say we'll show the current frame rate of my scene at the moment. So where is my, that's right. Firstly, I'll add a vertical box because I just want to make sure that this has, sorry, get in there. There we go. Cool. Set the anchors just to make sure it fills all of the available space. There we go. And I want to do something like enable FPS statistics, right? So for example, I can go to the graph, I can select my button, and down the left here, you can also do this from the designer. So if you select the button, we can scroll down, hit pressed, and it'll create an event in the environment or in the graph. You can do this from here as well. There's a couple of other ones like on hovered, on unhovered, so you can give different functionality based on that. And what we're going to do is we're going to execute a console command. So in here, what we can do is we can use one of the most common used console commands in all of Unreal Engine's existence is stat FPS. And in here, we'll rerun the editor utility widget. We'll hit enable FPS statistics.
Might be worth docking that.
Yes. So you can drag this around, and you can see that I can dock it in many areas. So if I want, I can just put it over next to the details panel. If I keep tapping that, it'll just toggle that FPS statistic on and off. And you can even see in the output log, this is super handy as well. I don't think we've actually covered this, have we, Chris? The output log is a trove of information. So if you go to Windows, Developer Tools, and then click Output Log, it will show this up. It will give you information about what's happening currently in the environment, or currently in the editor, or at runtime. You can also filter and choose which categories to enable and disable. Pretty handy. So enough of fancy buttons. Let's do something a little bit more advanced. So what happens if I want to create something like a method to scatter objects in the environment? So maybe I've got some of this trash, right? We put it around the environment. We go, yeah, let's rotate it around, put it in, and it just feels not really organic, right? Maybe we can create a tool that scatters this around for us. Like, we do have the technology, right? So let's go back into the designer. I'm just going to delete this. And what we want to do is we're going to go back to those unit vectors again. And what we're going to do is we're going to say, given a direction, which we can specify using our UI, let's provide a unit vector and then randomize a launch angle. So we're actually going to shoot this garbage bag around the scene, right? So we'll randomize the angle to give it a bit more of a organic feel. And then what we're going to do is we're going to be able to specify the launch velocity. And from the unit direction, the angle, which is fuzzy, it can be randomized, and a launch velocity, we can generate an arc that then says, hey, let's imaginarily throw this garbage bag in this direction until it hits the ground, and then it'll stop, right? Sounds pretty easy, right? So let's do it. So in our graph, we're going to start creating a couple of variables. We'll create our launch velocity. We'll give it a float type. So a float in Unreal Engine is something that has decimal numbers. An integer is a whole number. We'll give it a direction in the X direction. Now, normally you would use a vector for this, but unfortunately, one of the widgets that I'm about to use can't render it, so we're going to do it a little bit more manually than normal. We will make firstly, let's delete this. We will specify that the slider range can only work between -1 and 1. Same with the value range. And this will help our editor UI because we can clamp stuff. You'll see it in a tick, just trust me. And what we'll do is we'll duplicate this. Now I don't have to repopulate those slider ranges, right? We'll give it an X, Y, and Z direction. So as Chris said, if you're fully in the +1 direction of direction X, you're going to go this way. If you're in the Z direction, Z is up in Unreal Engine, by the way, it'll be +1 in this direction, and then a combination of that will give you different angles, right? Different directions to throw from. And now there's one last one that we need to provide, right? So it is launch velocity, direction. Let's start with that. It will come to me in a tick. Let's create a couple of these little widgets. So we've got this special little editor section. Now this only shows up if you're creating UI for games, because this same tool here that I'm using for the editor is also used for games. UMG is pretty powerful. You can do animations for the UI as well. So this is something that you will be using for maybe some credits at the end of your film maybe. So definitely get onto it. And credits are pretty easy. You can totally just add a widget with all of your credits listed in a single widget and then just put an animation on it, let it play for, well, let's say 20 seconds or something like that, right? But anyway, in our case, these two editor widgets only show up for editor utility widgets because, once again, we're in the editor context, right? So let's drag in a single property view, and we're going to call it prop view, and then let's call it velocity. We're going to specify the property name as launch velocity because we want to access this value. We'll compile, hit graph, and then in our pre-construct, so this happens before any UI rendering happens. So it's kind of like in a normal actor, begin play, right? What we're going to do is we're going to set the prop view velocity as object. And right now, this property UI widget has an undefined object, meaning that even though it's got a property name, we know that the property is this, right? But we could use this single property view to point to another object in the environment, maybe another actor or anything in the environment. Maybe you select on something and you go, hey, I want to show the velocity of this actor, right? Or something like that. So let's use the single property view and then set the object to be that actor. In this case, we've got an instance of this scatter, which is an object. And we'll set it to ourselves, which we call self. So if object-oriented programming is new to you, Blueprints is object-oriented programming. Don't be scared. Imagine that a blueprint is a stamp, and then the object is the ink that's on the page. So what you can do, like with actors, like a decal, or so this decal is an instance of a class, right? The class being a blueprint. So imagine every single time I use the stamp being the decal actor class or blueprint, I stamp down, it creates another instance, and that's an object. I stamp down, creates another instance or an object. It's like duplicating, right? So in this case, when we run our scatter, we run editor utility widget, and it creates this BP scatter, right? It's created an instance of this blueprint. And so what we're doing is we're saying, telling this property view that, hey, look at this object to find this property. And now you can see that it shows up here. So if I go into the default value of this and hit 500 and compile, you'll see that it'll populate in the widget just here. I'm gonna just give it a little bit of padding because I'm a little bit anal about these things. And so we will now start making more properties. So for example, we'll make a couple of property views for our direction X, direction Y, and direction Z. So I'm going to create a horizontal box. And this horizontal box allows us to put widgets from left to right. A vertical box allows us to go from top to bottom, right? And there's also a grid, so if you want, you could do a 3x3 or something like that, right? And what we're going to do is we're just going to give ourselves some context. So we'll call this direction. I'm going to change the font size because quite large. I'll make it 12. Totally broken this out, haven't I? Yeah, sorry. we'll give this more padding. This is superfluous, but it'll make it easier for people to read. And we'll add a couple more property views. So we'll add onto this. We will rename prop view direction X. We'll duplicate. You can hit Control W to do that. F2 is rename. And then in here, we need to set the property name. So this is direction Y, direction X, direction Z, or Z. And once again, we've got these little undefined objects, right? So we can do the same thing here. So we can create another call to set this property view to target, and then the object to ourselves, because remember, once again, we're reading a property called direction X from another object. This other object is us. And a little known tip is that some of these, if you have a couple of variables that use the same base type, you can actually call, instead of doing one at a time like this and having to copy paste and move this over here and then do another self like this, right? Instead, you can just join them all up to the one target. And the engine will already know, oh, okay, you want to run set object of self on each one of these. Nifty tip, great. So we'll set object, we'll compile, we'll save. We can see that our directions are now up. And you can see the fruits of our labor. If you remember back before, I set the slider ranges and value ranges here. And when we scroll back and forth in this slider, I'll make this a bit bigger. You can see that it caps. I can't go below -1 and I can't go above 1. And this is going to be useful because obviously a unit vector, a single unit, can't be bigger than 1. Now, what we're going to do is we're also going to add a button. We all love our buttons, right? So let's add it to the end of the vertical box. Nope, I don't want that in there. We're always going to do X, Y, Z. And we'll give ourselves a bit more padding again, because everybody loves padding. We'll center it. We'll add a bit of text. And we'll call it scatter. And we could give this guy a little bit as well. And let's give it 20 and 5. So we've got 20 bits of padding on the left and right, and 5 up and down. And in here, once again, we can go down here and hit plus on pressed. It'll create ourselves a button. We'll get rid of the old one because it's not useful. And we can do something with this. But to further demonstrate what I'm about to do, what we're going to, we need to visualize this, right? Because you don't want to just wiggle around a couple of buttons and go, I don't know what that looks like before you hit scatter, right? Because as soon as you hit scatter, it's being done and you may not like the result. So instead, what we're going to do is we're going to on tick, we're going to just iterate through all of our selected actors. So we might select this set. And then what we want to do is say randomize a direction. Let's throw them off into a direction, right? So let's get level selected actors. We'll iterate through. Also just do a, actually no, that should be. We'll iterate through. And what we're going to do is we're going to get our actor location. And then we're going to do something called a predict projectile path by trace channel. And what this does is it creates an imaginary line that, or curve, that when you tell it to start at a particular position and launch at a velocity, it will simulate gravity for you and essentially do ballistic mechanics, right? So if you fire off into this direction, it'll go up and then come down and then hit something. And that hit something is what we call in the engine tracing. And the trace channel, what we want to do is we want to only trace against stuff that we can see. So let's set the visibility channel. And we don't particularly want to hit each other. We could potentially just say ignore one, but we'll ignore each other for the purposes of this demo, just to make it easier. So we've provided, we'll provide the start location, which is our actor's current location. And then we need a launch velocity, right? Which we have here. We've got a velocity, but it's not a vector. What do? We've got a direction. So let's think about this. We have a direction, we have a launch velocity. Maybe we can start maybe shooting it in a particular direction at a certain velocity. So with this, we can say, get our X, Y, and Z. We'll make a vector. We'll join them up. And we'll do something called normalization. And this just ensures that the total length of that stick that's pointing in a direction is only one unreal unit, which is 1 centimeter in the real world. We'll then multiply that by the launch velocity. So now that 1 centimeter in this case is 500 centimeters, and this can stand for 500 centimeters per second. So now you can start seeing a little bit of the usefulness of the math behind this. We can plug that into the launch velocity. And in here, we can leave the rest. We can specify the max simulation time. The lower you go, the cheaper it is, but the higher you go, the more accurate you'll get. Otherwise, you might finish the simulation before it's done. We'll leave it at 2 seconds. It's been pretty good so far. Most of the time, our object's going to be on the ground, and 2 seconds of free fall is probably pretty extensive. And what we're going to do is we're going to do something called draw a debug line. So you might have noticed I connected the world context object up to the actor. Now, what most functions do when they see that world context object, you don't always have to do get world, right? You could if you wanted to. If you wanted to be explicit, that's totally fine. But what they do is they actually say, oh, I've been provided an actor. Let's just use its world. Right? So because we know where it is, we know that it's in an environment in a level. So let's just use that. And same thing with this draw debug line. We've got a world context object. This draw debug line, it will go into the environment and it will just draw like just a very thin line. You can change the thickness, how long it lasts for, the line color. So if I want, I could make it a good old red line. Start rendering that. But what we're going to do is we're going to, because our projectile is, or we're calculating some ballistics, we actually get a list of positions. So in our case, what we're going to do is we're going to say for, we're going to actually get the last index of these positions. And we're going to iterate through them, but we need to iterate them in segments. So we're going to do something a little bit more intelligently. We're going to loop up until the last index, but we'll only start from the second position, right? Because we need a line. We need to go from point A to point B, draw that. Then point B to point C, draw that. Point C to D, and so on and so forth, right? So in our case, what we're actually going to do is we're going to say, get ourselves our position. So we start at the second position, and we want the previous one to that, right? Because this is the end of the line, and we want the first to be the start. So we always have kind of like this hopscotch kind of deal, right? We always hop over the top of ourselves. Our duration can just stay at 0. We'll make it green. And our thickness, let's make 3. Give it a bit of thickness, right? So we've got a vector, a launch velocity. We're iterating over the results. Now, we might get to a situation where we don't have a result. So let's just only iterate if we have something, right? Now, when we select this, we'll provide ourselves a direction. And am I missing something? Sorry, folks, give me a tick. And normalizing, we've got the direction. We'll provide a default up. We have a launch velocity of 500. That should shoot it straight up. We will change the direction here. There potentially might be a collision in the way in this. Maybe. That's why. The actor locations, you can see where the pivot is. That was just below the floor there. So that's a little bit of a gotcha. Because we're doing our collision tests from below, they'll collide with the environment below. So now you can see that it only calculates that from the ones we're using. And as we modify our direction, you can see this is a perfect example of our little unit vectors, right? We might actually render that unit vector just to show you where that's going as well, but you can see where that's going. If I want to go in the Y direction, you can see that Y in this case is on our gizmo, the Y direction there, going back and forth. Pretty handy, right? Super cool. Then obviously if we want to go underneath, we can go -Z. Cool. So what we are going to do is we will then do the scatter when we've pressed our button. So let's do something similar to this, right? So let's go back in. We'll do our collapse to function because we can just reuse this, right? Pretty handy. We will get our scatter position. I'll clean this up just so it's a little easier to read. Down here, we've got the array element. That is not what I need. Apologies. That's not what I should be doing. I will undo that. Here we go. Sorry, folks. Should not have done that because I just realized I should be going through each level actor anyway. So in this case, I've actually got to collapse this guy. I went one too far or two too far with the loop. So let's collapse to function. Get projectile path. Cool. Now we'll clean this up. Sometimes UE doesn't understand that when you collapse to function, some of these should just link up and be reused.
As a heads up, if you want to do that cleaner next time,
This,
what you can do is you can collapse.
we could probably remove the world context object and then pass that guy into here. We've got the actors to ignore. Now, a little performance tip for large things like arrays, sets, and maps. You might want to pass by reference. Usually the collapsed function does this automatically for you because it's smart like that. Return a number of positions from here. Yep. We'll disconnect this. We're good now. Cool. So we're still drawing stuff, still dandy. Let's go down and we will do something similar again. So we still want to go through, still want to get our selected level actors, get our projectile. Ooh, have my...
Could you hear me? Yeah. So one little thing to help out with the issue before in his collapse nodes is you actually can create a reroute node and then collapse on that, and it will keep everything together.
Yes, thank you, Chris. Sorry, I must have accidentally bumped the mute button. All right, cool. So yes, for people who heard that, you can create a reroute node by double-clicking halfway through. And this is actually quite convenient because you could do something like this, right? Where you have a redirect that jumps in, and instead of having spaghetti going absolutely everywhere, then you can just split them out to multiple things. Super, super handy. All right. Now, so same thing with our scatter. What we're going to do is we've got our projectile path now. Thankfully, we've been sharing this functionality. Get our projectile path, and we will then loop through it. And to do this, what we want to do is we want to kind of simulate how these actors are going to fly through, right? So we've got our ballistics path. We know which way they're going to go. And what we want to do is we want to have them kind of like simulate. We're not going to visualize a simulation because that's the little green line, but we're going to simulate how they fly through. And if they hit anything, then they just stop. And in this case, what we're going to do is we're going to set the actor location. And we're going to do something called a sweep. And this is a cheap and easy trick to do something like this, because what a sweep does, it essentially, I'm going to get physical here. A sweep can say, if I move to a new location, I'm going to make sure that I activate my collision response. So if I say I want to move from here to here, it will sweep the collision until it hits here. And if it hits something, it will just stop, right? And that's super handy in this case, because now, instead of just following the path, which might take our little actor through the ground or something like that, or maybe we've got a pivot point that's a little bit more central. Like if we picked on this little fella here and he went through the ground, right? You can see that if I moved it to this position, it would actually be the pivot point that places there, right? And it would be clipping through the bottom of the environment, which isn't exactly optimal. So what we're going to do is this sweep, and this just means that it stops before it goes through the ground. So in here, we'll do our direction, and we'll hit scatter. So now you can see that it's completely flush against the ground. However, you might be asking, but Alex, this is totally reproducible in the same direction for everyone, and it's not really useful. Why would I just want to like hit scatter in one direction? It's a little bit boring, right? Instead, what I would be wanting to do is we might want to add another property here for randomize angle. So in here, let's do another duplicate. We'll call that max angle. and we'll give it an angle between 0. Yep. I'm so used to Visual Studio. It's not funny. And we're going to do another one of these fancy little property views. So we will duplicate this one. We'll drop him just below there. We'll call it max angle because we've called it max angle here. And you'll notice once again, we've got an undefined object. So what do? We can go back up to our pre-construct. I'll rename it. We won't bother just yet. It can be renamed in a tick. That's our property view to our max angle. Random caps. Setting off eye twitches since forever. And now what we can do, this is what I was mentioning before, once you collapse to a function, we can just modify one place and it propagates everywhere, right? So we'll go in here, and what we're going to do is use a node called getRandom, random unit vector in kern in degrees, not normal, but from stream. Now, I'll show you the normal. This is what happens. It's not quite useful, and I'll explain why in a tick. We'll give our max angle not 500, because that's obviously over the edge of a kern, because what we want to do is we want to say, hey, we've got our little stick, it's pointing in this direction, right? But we also want to give it a bit of a fluffy direction. So let's use a kern for that. So let's just choose a random direction within that kern to point in any way around that and just keep it within that area, right? So let's keep it to let's say 60 degrees, the default value. And you'll see that it's just flying around the place, right? Now, the reason for this is because those are running on tick. And this random unit vector uses something called a pseudo-random number generator. And every single time it gets called, it updates that number and it provides a completely random result again. So every single tick, we'd randomize the number. It's not useful, right? So we could either call that and then store it until we hit a button, or what we could do is we could do something called a random stream, which you provide the seed to, and the seed kind of ensures that the pseudo-random number always regenerates the same values every single time. So now you suddenly get some stable random values. And that sounds super counterintuitive, but it is something that is super useful for procedural generation in games. So, for example, if anyone has played Minecraft, maybe, you might notice in the top right-hand corner when you start, I think it's top right, it's been 8 years since I played that game, but there is a random number up there that is used as the seed to generate that world. And we're going to use some similar concept for this. So what we're going to do is random unit vector in degrees from stream. We'll provide the max angle. We'll feed that in. And we're going to keep some form of globality. So we're going to actually store this in a global context to store that value across one whole tick, because every time we go into this tick and we call it projectile path, if we had a random stream update in there, it would always update for that one projectile, right? But we also want to mix up the numbers between said actors that have been selected. So what we're going to do is we'll create this random stream. And to create this quickly, I've just right-clicked and then I'll disconnect that and then promoted to variable, and it already created this for me. And every single time we start a new frame, what I want to do is I want to reset the random stream. And now you'll notice that our stuff in the background has stopped. So now every single time I rotate or change the max angle, it regenerates that position. Now, to give it a little bit more fuzziness, we can also put in another variable called a seed. And so what we're going to do is we'll call that an integer, or we'll call it seed of type integer. Compile it, give it just a random, let's give me a random value. And whenever, instead of resetting random stream, which resets the initial value to 0, we're going to set the seed. And this will allow us to eventually just dial a little slider to also mix things up for us. And we'll also have to do this before this over here, because if we don't reset the random seed here, this projectile path will continue using on the random generated values from the last tick, which will mean that the result is different to what you're seeing on screen here. So we still need to force it to start back again at that initial seed. Now, don't worry about the details, just understand that it kind of makes sure that the numbers that get generated are the same every single time it's called. As long as you're calling them in the same order, that is. All right, so got the random stream. Let's now, once again, do a property view. I'll drop that in here. We'll call it a prop view seed. We'll call it from the property name. Once again, we've got an unidentified object, or undefined object, I should say. And we can drop this into our target, hit compile, save, and now we can change our seed. And now we've got a super handy random generator that can move positions. Sorry, they're hitting each other. So let's move these guys. They potentially are hitting other. So that's post-process volume. Click this around. We'll hit scatter, and you can see that they're moving around in the environment. We can change their max angles. They'll regenerate stuff for us, unfortunately, but that's fine. And they can move around. We can play around with the seed. And not only that, but what happens if we move all of our stuff over here, and we don't want to just select everything. We only want to select all of this stuff in one direction. Maybe I want to move all of the decals, right? Now I've already got a tool to do that, right? So I've only selected the decals that I want. We can scatter those. There, once again, they're underneath. So let's scatter our decals a little bit. How handy is that, right? That's pretty cool. So, are there any questions?
There's one, dude.
Cool. And right on the dot too. Well, 2 minutes over. I apologize. But do we have any questions from the stream?
Just pulling this back to our cameras now for the UI.
Cool.
So just be 1 second. Cool. Great. So that was a lot of content that we covered today. My apologies for any folks that were coming into this expecting a very light touch. Hopefully, we did a good job of showing some of the cleaner, simpler stuff, and as well as some of the potentially like advanced reaching and where this could go in the long run. Obviously, we have the stream saved as well. So if any of Alex's stuff kind of went over your head, you're more than welcome to assess that as you see fit, and kind of scrub back through it as necessary. But in general, ideally, the session for today was to kind of aim for two-part. One was to educate, and one was obviously to inspire, so that folks knew not to write things out from the get-go. And if you're building a certain kind of project, then being able to kind of have something to guide that is super important. So if we have any questions, let's field them.
I see a lot of brains melting from ears.
Yeah, you may have hit them a bit hard with some of the vector math earlier on.
I'm apologizing in advance, but definitely go through the stream again.
Look,
and if you have any questions, feel free to hit up the SFCANZ email.
Yeah, it looks like for the most part, I think we're good on the questions. I have a question. Is it true we should avoid casting where possible in VPs? I mean, so the question was about whether you should be casting in blueprints or not. This is more of a game question than a film question, because you're probably not going to have performance issues with that in film. But to answer that question, it's really just if you start seeing performance issues, or if you're expecting to have to call that a whole lot of times, that's one thing. In Blueprint, it's often better to use interfaces and or casting to C++ classes, though, as that prevents you from having to load whatever you're casting to into memory. It's a much longer discussion, I suspect, since we are getting some folks discussing their eyes glazing over. But the long and short of it is simply, if you cast to something when using Blueprint and you're casting to another Blueprint, it will have to load that into memory, which is fine if those two things are almost always going to coexist and you're just checking. But if these two things aren't necessarily going to coexist, you're now forcing them to coexist in memory.
Yeah. And there's actually a really good stream by Christian Allen on something called soft object references. Definitely check them out, because it helps you save memory if you do have issues with that. There is a big thing in games that don't optimize prematurely, because you'll just waste time. So it's always a balance about workflow. Luke Harris asks, my only question is about the repeatability of AI performances. I'm guessing the answer lies in the seed for random.
It's both in the seed for random, but also, honestly, just for AI stuff, quite often what you want to do is just record those things back to sequencer. Like, I was using them because hand animating, if I want to have 50 people in my scene walking around doing nicely blended animations that look good, there's a good chance that I just want to run that script and then record them and then move on with my life. Seed for using a random seed for certain things like the locations and such could be a good move, though. But ultimately, for film and TV, like at the end of, once you've gotten the thing that you like, you do probably want to be baking that down in sequencer to just guided tracks. The answer there was Christian Allen. He's okay, there you go, never mind. Alex is on top of things.
Yeah, look up demystifying soft references or soft object references.
Look, I think that was it then for the session. I hope this was useful to everybody. I know it may not have been what you were expecting from a film and television class, where here's how to make a very light video game and throw trash bags around subways. But hopefully that also meant that there was a bit of education in there in the process. So I'll see some of you later for the VFX talk, and then we have one left before we cycle around, which is Tech Art on Monday, but we're nearly through the first wave. So once again, as far as resources are concerned, by all means, check out the Unreal Engine Virtual Production Facebook. It's unofficial, but it's great. Checking out the Unreal Engine Australia Facebook group as well. And the Unreal Engine Discord is really wonderful too. We've had a few questions here come up regarding the last couple of sessions. So tech art is going to be advanced material work and cool effects you can do on the blueprint side and on the material side to create visuals that you may not have previously thought you could do, or to take shortcuts that you may not have considered as achievable. That should be a fun one. The VFX is going to be more about just running through the particle systems and the various particle editors and creating a couple of advanced effects along the way. So again, thank you all for coming. This has been a fun chat. I got to say, it's nice that I can take my hands off of the controls and kind of monitor that while Alex was running through this one.
Yes, nice to have a voice.
Yeah, we've switched spots. But yeah, so hopefully we'll see some of you in the session in a couple hours' time. Thanks for coming.
Thanks, everyone.
Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm?